Oh, this is section 3.2. We're talking about how do I solve equations using multiplication and division. So multiplication and division are inverse operations. They undo each other, like before we were talking about how addition and subtraction undo each other. So here's the questions we're going to ask ourselves. We're going to ask ourselves, what side of the equal sign is x on? What's being done to x? And then how do I undo what's being done to x? And we're going to undo dividing by multiplying, and the inverse of dividing is multiplying by that number. And we're going to check to see if that answer is true by substituting it back into the original equation. If the result is true, it is a solution. So here we go. Let's try these examples here. So here we're going to ask ourselves the question, what side is x on of the equal sign? It's on the right side of the equal sign. What's being done to it? It's being multiplied by 4. So how do we undo multiplying by 4? We divide by 4. And what we do to one side, we have to do to the other. So on the right side of the equal sign here, taking x and multiplying it by 4 and then dividing it by 4 really just leaves us with x. Well, so awesome, that's going to be our solution. What does x equal? X equals whatever this simplifies to. 12 divided by 4 is 3. So x equals 3. And if you substitute it back into the original equation, 4 times 3 equals 12. Bada bing, bada boom. Second example, what side of the equal sign is x on? It's on the left side. What's being done to it? It's being multiplied by negative 5. How do we undo multiplying by negative 5? We divide by negative 5. If you take some number, or some value x, and multiply it by negative 5, and then you divide it by negative 5, those two operations will undo each other. So if I divide the left side by negative 5, I have to divide the right side by negative 5. So x equals whatever 40 divided by negative 5 is, which is negative 8. All right. Whoa, that's a messy 8. Well, that's not any better. Third time is a charm? Yes. If you substitute that negative 8 in, what is negative 5 times negative 8? 40. Boom. Let's try these. What side of the equal sign is x on? Whoa. X is on the left side of the equal sign. I like to make it more of a dashed line. X is on the left side of the equal sign. What's being done to it? It's being divided by 5. How do you undo dividing by 5? You multiply by 5. So I'm just going to put a little dot here for multiplication. And what you do to one side, do to the other. So these are inverse operations. They undo each other. So x equals whatever 3 times 5 is, which is 15. If you plug it back into the original blue equation, 15 divided by 5 is 3. Bada bing, bada boom. Over yonder, what side of the equal sign is x on? It's on the right. What's being done to it? It's being divided by negative 3. How do we undo dividing by negative 3? Multiply by negative 3. What we do to one side, do to the other. Multiplying and dividing by negative 3 are inverses. They cancel each other out. So we have x equals, there's a multiplication sign there. It looked like negative 32 for a second. Remember, we're timesing 2 by negative, or multiplying 2 by negative 3 over there. So we get negative 6. We could rewrite that as x equals negative 6. Boom. Lastly, what if, oh my gosh, what's being done to x over here? It's on the left side. It's being multiplied by 2 and divided by 5. Or it's being multiplied by the fraction 2/5. We undo multiplying by fractions by multiplying by the reciprocal. So 5/2. And what we do to one side, do to the other. Note that 10 is a numerator. What's 10 over here being divided by? If I were to make it into a fraction, recall when we were talking about slopes, so we haven't talked about that yet, but 10 is the same as 10 divided by 1. And for many of us, it's going to be helpful when we're multiplying a number by a fraction to make that number also a fraction. So we're kind of speaking the same language. It's a fraction times a fraction. Believe it or not, folks, taking x times 2/5 multiplied by 5/2, the fractions are going to undo each other. So we're left with x. Hey, we have gotten x by itself. We've isolated x, multiplying by the reciprocal is an inverse operation. Then we just need to simplify the right side here. So when we multiply fractions, multiplying fractions is the easy one. We just multiply straight across. So we get 50, and I'm going to actually work straight across here. So on top we get 50. On the bottom, 1 times 2 is 2. So that equals 25. Check this out. Let's go back to the original fraction. So let's substitute in 25 here. So 25 times 2 is 50. So this top part actually simplifies to 50. What's 50 divided by 5? It's 10. Yes. Second example, over yonder. X is being multiplied by negative 4/3. So to undo multiplying by a fraction, we multiply by the reciprocal. So it would be like 3/4, but it needs to be negative. So technically we should put the negative sign up top. Put the negative sign down with the 4 because like the 4 is negative for the other fraction. That's fine too. What we do to one side though, we have to do the other side. So I need to multiply this side by negative 3/4. And since this is not a fraction, let's make it a fraction so we're speaking the same language. So here we go. On the left side, these are inverse operations. They undo each other. You know, you would get negative 12 divided by, you get positive 12 because a negative times a negative is a positive. So you get 12 divided by 12, which is just 1, and then you have 1x. On the right side, 8 times negative 3 is negative 24, divided by 4 is negative 6. I believe I did that kind of quick though. Maybe I goofed up. Let's check it. When we take negative 6 times negative 4, we get 24. 24 divided by 3 is 8. Hey, that's got to be the right answer. That's awesome. That was kind of fun. Let's give these a shot. So here, x is on the left. It's being multiplied by a fraction. So reciprocal that fraction. My puppy over on the couch is getting pretty excited about this math. To reposition himself for the nap. So multiply the left side by 5/3, multiply the right side by 5/3. These are inverses, they undo each other. We get x equals 35/3. That fraction you can't simplify, so just leave it. Here, x is on the left, it's being multiplied by negative 3. So we divide by negative 3. What you do to one side, do to the other. X equals negative 2. And if you plug that back in, like you should do, especially on quizzes and tests, make sure you know how to check your answers, so you can do it when it really counts. Negative 3 times negative 2 is positive 6. Here, x is being divided by 5, so to undo dividing, we multiply by 5. What you do to one side, do to the other. So x equals 10. I'm not going to check the answer there. Make sure you know how to do that. Here, x is on the right side of the equal sign. It's being multiplied by negative 3, so we divide by negative 3. So we get x equals 4, positive 4. Boom. In this one, x is on the left side of the equal sign. It's being divided by 3, so multiply by 3. What you do to one side, do to the other. Boom, boom, boom. Whoa, that's a bad cross out. X equals negative 6. Last but not least, x is being multiplied by a fraction. So we multiply by the reciprocal. Whoa, the reciprocal, hello. Now, this is a negative fraction, so this also needs to be a negative fraction. So, because a negative times a negative is a positive. I'm going to stick the negative sign up top. If you left it on the bottom instead, that'd be okay. In fact, I'm going to even, I won't do that. I retract my comment that you didn't even hear. So, multiplying by the reciprocal or inverse operations, we're left with x. And then we get negative 35 divided by 3. Boom.